So thank you everybody for being here. Glad to see some faces despite the lunchtime. So, hacking the planet with knowledge graphs. I won't forgive the conference organization for missing that part. So, what we were talking about here, as I said, is extremely complex environments, and it is going to be based in my own experience in dealing with them. And I don't know what that happens, but I couldn't fix that in the last 2 hours that I was trying. So, first of all, who is this guy? Well, I'm as they say, a commercial pilot. I've been doing aviation cybersecurity and other OT cybersecurity for almost 16 years now. And what we're going to be seeing here is actually the outcome of the experience accumulated over the last 16 years. But first of all, the first disclaimer. I am here speaking on my own behalf. I am by no means representing my employer. My opinions are my own, and they do not express the views or opinions of my employer. You know how the deal goes, right? So whatever you hear here today is just about me. It has nothing to do with my employer. The second one, we're going to be talking about graph and graph theory here today. And I read once in a book that for every formula that you put in a book, you lose half of the readers. In this case, presentation. So I'm going to avoid them. I'm not going to put any single formula. What I want to say with this is that I'm not actually tell you how the underlying part works. I'm going to share with you is the idea, the concept, and the implementation. Okay, but I'm going to leave the mathematical background for you to further study if you want, even though it's not really necessary for a practical application of what we're going to be talking about today. So, first of all, the problem. Every time I come to a conference is because somehow I managed to find a problem, and also somehow I managed to either overcome it or I failed. And in any case, I consider that the experience has any value for more people. What is the problem that we're going to be talking about here today? It's sizing problem. It's a complexity problem. It's not about the technical expertise on the target. It's not about the type of the target. It's not about the specific defense mechanism. It's about complexity. Again, the final disclaimer, and I promise is the final one. Okay, what follows and what we will be using during this presentation is fictional scenario. It is based in Dubai. It is based in actual places of Dubai, but I just did it because I happen to live there. I know the place well because I thought the people here would relate with Dubai, but that's it. Okay, any resemblance with any reality is just a coincidence, and because I'm going to be talking about some technologies that, well, no matter what I select, is going to be represented there. Okay, so what happened to me? Okay, so you move to Dubai, you start working for a company, and you are in charge of the cybersecurity of specific amount of technological landscape. Okay, and over the time, you start to realize that maybe that landscape is a little bigger than you thought initially. So for starters, being as I am an aviation person, one of the first things that you have is airports, international airports. Two, actually, why not? One is never enough. Let's say that one fails. You have a backup international airport. Who cannot have a backup international airport, right? Okay, obviously you have an airport, you're in aviation, you also have airplanes, hundreds of airplanes. Okay, also your responsibility. Again, if you have airports and you have airplanes, well, you also need some fleet of automotive to glue things together. You have hundreds of cars, you have thousands of trucks, and you have hundreds of buses, for example, to move passengers, to move pilots, to move cargo, to move fuel. Okay? Because obviously, if you are in the transportation industry, you just don't limit yourself to people and passengers, you also move cargo, right? And once the cargo reaches the airport, it needs to move further. For that, the trucks are very handy. Of course, if you're in the travel industry, you're going to need buildings. Why? Well, it's a company, it's going to need a headquarters, it's going to need additional buildings and offices. But of course, if you're a company in this type of industry, you're going to need, why not, hotels, for example. So the passengers, they pay for the flights and then they also pay for the stay and they only pay to you. So you happen to have a bunch of very nice hotels with their own building management systems, of course, right? But we don't stop there. We also have related industries that support all that have their own industrial control systems. You have to maintain those airplanes. Those have industrial control systems. You have to provide food to the passengers. So you also have a branch that takes care of preparing the cook. And you're not going to do it manually. You can have a building automated to do it for you. And so on, and so on, and so on. And we don't stop here, okay? Because obviously you have that. And you're already moving things and cargo. Why don't move it also over the sea? So you also happen to have ships, okay? So you happen to have a bunch of hundreds of ships as well. And you don't stop in one country, of course. Any respectable company nowadays has to be international. So you spread that all across the globe, okay? Now, as you can see, you started to grasp the complexity and the sheer size of this hypothetical scenario, right? And all this technology, being a modern company, is not isolated. All of it is connected. You have the transportation vehicles. You have a fleet management system that obviously is centrally managed through cloud and IT and internet or whatever you want to select. The airplanes connected obviously between them with the airport traffic control and so on, so on. But we do not stop here in the purely technical relationship between the systems. There is operational relationship as well. So is the car connected to the airplane? No. But if the car is actually moving the pilots to the airplane and the car fails, the airplane cannot take off. Because without pilots, well, you cannot fly, right? So there is other complexities here other than just the purely technical ones. Those are also presented here, okay? So now that we have this very high-level overview of this hypothetical scenario, and pretending that you are the ones sitting there one day in the office after having performed this scope analysis, the question that I shouldn't be doing is, where would you start? And actually, I know I shouldn't do that. I've been training presentations and they always tell me, do not engage the attendees and all that. But I'm not going to move from here until at least one person gives me an answer. And I think I can do it with these headphones here. So please, somebody, one answer. Where would you start? Seba. A plane. Any other question? Sorry, answer? Come on. I have 10 times the amount of people I was expecting. Somebody must be brave enough to give me an answer. No? You're smiling.
Headquarters.
Huh?
Headquarters, server, central group.
Okay, great. So I got 2 answers. 2 more than I was expecting. And I missed. Because every time I do this exercise, somebody always says from the beginning. And I failed this time. I'm sorry. I was trying to lure any of you to say me that. Okay, so that's part 1. Establishing the background, the scenario, the problem, okay? And that is with many, many, many differences, but in terms of scale and complexity is quite similar to some problems that I have faced. So, not the approach to solve that, but the approach that I took, okay? And in order to do that, you need to know something about me. And it's not a disclaimer, it's just a fact. After many, many years, knowing that I was weird, but I didn't have a name for that weirdness, I realized and I found out that I am what they call the visual thinker, okay? And that is a person that sees the world and organizes the information and consumes the information in a completely different way. I'm going to explain you that because it's actually quite important for the rest of the presentation, okay? But first, let's do one quick test, shall we? Okay, I guess by here, you are used to do many types of cybersecurity activities. Some of you may even be reverse engineering or at least do some binary analysis, okay? So, first, a visual thinker, it's a person that you give a binary or a piece of information in this format to the left, and the brain just freezes. My brain doesn't like it, okay? He just hides, avoids it, tries to look for patterns, and things like that. It just doesn't happen. Instead, you give exactly the same piece of information like that, in the form of a nice graph, and my brain is completely comfortable, it's happy, it's smiling, it's able to process the information, to extract patterns immediately. That's the type of person that I am, okay? And I actually think and believe, truly, that there is a lot of value into that. Now we're going to do the test. First of all, in 5 seconds, or 3, what can you tell me about this piece of code that you have here if you happen to be a reverse engineer. Okay? 3, 2, 1. Anybody? Now, let's look at this. That's a part of an application that I developed. Over there, you have a nice graph that is telling you that actually it's a quite small function of a program that it's actually using a lot of external connections to other operating system functionalities, but it only happens to have one exit point. And then you take a look at the graph on the left, and you see that it's actually just doing a basic checks and going out early if you don't meet the requirements on that part over there, and if not, it's just going to go through the main functionality, just like that, 5 seconds, right? That's the type of way that my mind works, right? So my approach to the problem, it all happened by accident. I didn't plan any of it, okay? I'm not bright enough. It just happened that way. So by now, with what I explained to you, okay, you may understand that I actually take notes, not writing, but I draw. I draw diagrams during meetings, when I study, when I read, anytime. Okay, you take a look at my notebook over there, and it's plenty of drawings. There's no text. Okay, let's see some examples. And let's start, of course, being myself, with an airplane. Okay, so let's say that you want to analyze and learn and study and understand a new airplane. Okay, the first thing that you do is you collect all the information available about the airplane. You go to engineering, you go to flight ops, you go to the OEM, you collect all this amount of documentation in text, and you study. What would any other person do? They would take notes. So you get text, and you create notes. So you take text and create more text. I simply do not understand it. I don't see the point of that. Right, you get this amount of text, and you create this amount of text. But what do you do with it? It's still text. You put it in a document management system, you index it. What do you do with it? You create tags in your, it's just text. You cannot do anything out of it, right? What I do instead is I create a graph. I take all these and I create a diagram that explains and visualizes this airplane, the systems on the airplane. I take it all of there, but I don't stop there. Then I go and I add another diagram in which I go and take this relationship to outside of the airplane. What about the air traffic control? Is it connected to the airplane? Yeah, and I study also as well. Is it the airport also connected? Yes, it is. So I create another diagram. Okay? Is the passenger management system also connected to that? I create another diagram. Again, I don't stop there. I do the same for the building management systems. I do the same for the industrial control systems, the automotive networks, and the human factor. We'll see about that later, a little bit with some examples. Right now, I'm just setting the scene here. The details will come a little bit later. Although, remember, we're not going through the math, the underlying technologies for that, okay? Still, being cybersecurity, I still do not stop here. I also create graphs for the attack patterns that I discover or that are existing and that can affect all those systems. I also create diagrams and graphs for the defense patterns, for the detection rules, for the incident response management, for all those technologies that can be applied to defend those technologies that we saw. Still, don't stop there. Are there any regulations, any standards, any best practices and recommendations from the OEM that do apply to the cybersecurity of those systems? I also study them. The way I study, I create diagrams for them and graphs. And still, not just that. Is there any, being this cybersecurity at corporate level, is there any risk framework, risk methodology, any GRC that applies to those systems? I still do the same. And by now, you're starting to be bored. Like, this guy is just creating graphs and graphs and graphs and graphs. I agree. That's so far what I did. So what do we have by the end of this exercise? What do I have after 16 years of doing what you all do? Studying new technologies and creating and taking notes. I have, well, a bunch of graphs. Okay? That's what you will see. Okay? But we have a bunch of graphs that we can connect. Because we were seeing that. I'm not just studying any technology. I'm not studying any methodology. I'm studying the ones that apply to those technologies. And those are all connected. If they are connected in the real life, by technological means, operational means, regulatory means, they are connected here in the graphs, right? And you can further connect them. You can also connect, well, actually, that was the operational part, okay? So you can connect them by technology, but you can also connect them by operational limitations. You can even add business relationship here, brand damage, reputational damage, all that. So by the end of it, and it's no surprise, what you actually have is a massive graph of data, okay, or at least part of it. Why? Because I do not have the computational power to visualize the entire graph that I created over 16 years. But what I have in this diagram, in this graph, is the entire extent of knowledge, and not just the knowledge, the relationship between that knowledge. So in the end, what I do have is, you're going to say, yeah, great, we have graphs, we have a lot of graphs, we have nice visualization if you want, but what? Okay, what we have actually really is actionable data. And that for me is the key difference between having 200 documents, okay, or notes in OneNote, or in Apple Notes, or in your notebooks, okay, or having this. You cannot do pretty much anything out of just taking notes and doing summaries of text. But when it comes to that, you actually have actionable data. You can put that text if you want in an SQL database. So what? What can you do with an SQL database? You put data, you retrieve data. That's it. And you can do with that, it is actually much, much more than that. Because what you can apply to this is graph theory. Yeah, it's math. And yes, no, we are not going to see it. But this graph theory, it's actually the root of pretty much any modern application of data. That's it. You do data analytics, it's graph theory. You do any competitive advantage or relationship study, that's graph theory, because it's game theory that is based on graph theory. Do you want to do machine learning, which is part of AI? That's also graph theory. Anything that you or any modern company is doing nowadays with data is based on graph theory, and it cannot be done with any type of data. And it can be done with the one that we have here. So, the non-math use case, okay, a simple example on what can be done with this data, okay? And this is, again, a fictional scenario, or I mean, it's based on that fictional scenario, but the applicability, it is there, okay? So, let's say that we want to perform a security assessment of any type, risk assessment, offensive assessment, it doesn't really matter, of some part of this landscape, okay? We can start with an airplane. But you can just change in your mind airplane by another piece of technology complex with a lot of complexity and complex relationship, and it's going to apply the same, okay? So the first thing that we can do, thanks to that, well, we just can ask this graph, okay? Hey, give me this system or this subsystem on the entire system regarding this airplane. And it's there. You just need to tell it. You just need to write a tiny application and ask it, hey, please bring it back. And you don't even need to write it. I didn't write it. I just adapted one that existed. And instead of pulling the data from A, I just told it, hey, pull the data from this graph. This graph is just stored in a graph database. And it's going to give you all the commodities that you may need, even all the graph theory algorithms and functionalities. So in my case, I just got this diagram and say, okay, I want to see, and yes, it's not your glasses. It is hidden on purpose because, well, that's actually a little bit realistic data. But you just need to tell it, I want this system with this level of detail, and the most important part, I want to know any related systems with 1, 2, 3 nodes of difference. And it's going to automatically tell you all the connections. And you're going to tell it, yeah, but I only want the technical connections. For now, I don't really want the operational relationships, and it's going to be kept away. I just want to keep it technical. So they pull the system for you, and you have it here. That's it. No more brain. Now, the next thing we can do, for example, is, hey, now, as this is going to end up as a part of a risk threat modeling exercise, please, for the selected system, from the graph, pull me all the attack vectors that you already have that do apply to that system. And it's just a matter of expanding the search. You tell, now I want to look for nodes related to this system that has this attribute. It's an attack pattern, and it's already connected to here. And it's just going to be there, all for you. Again, the interface is not mine, but what do you see over there? This is the interface for a tool that is usually for the attack framework. I just pull it and change the source of information, but the interface is the same. What do you have there on the attack framework? You have a graph, you have a diagram. That's what I had. And instead of having to manually type it and look for it, I just told them, hey, for this system, just give me all of them. And you immediately have all those attacks, the ones that apply to that system. Now next, what about the defense? What controls do I have in place? What security patterns do I have for detecting those patterns that affect or can protect this system? That's also in the graph. So you have the system, the target, you have the attacks, and you have the controls. So you just can tell it, okay, so please show me also the attack patterns that are hidden because there is a security control in place preventing it from happening. Why? Because I want to double check them. I want to see if those controls are over there or not. You just need to ask it. It's another click. It's another filter. Data is still there, immediate. And still, there is no rocket science here. It's just a matter of connections. In a graph, looking for nodes. That's it. Okay? Because in the end, what it is, an attack. I mean, you heard that sentence about the attackers think in graphs and the defenders in checklist? Well, in my opinion, a bit stupid because a checklist is just another type of graph. Because I have proven it, right? So in the same attack framework type of approach, you can also put all the defense framework. And what do you have? Exactly the same. You just select the ones. The ones in red, there is a security control preventing it. Show it to me, and then tell me what's the control preventing that from happening. Okay? And here comes a funny part. What about the operational procedures applicable to the target? I mentioned that I included the human factor, right? How did I include the human factor? Well, why don't, if you heard anything about aviation cybersecurity, you always heard, but the pilot is there, and it has the last line of defense, and it's actually the one preventing things from happening. That I heard also, and I was told to me many times. So I decided at some point, why instead of fighting the pilot, I get the pilot to work for me. You heard that, right? Use the force of the enemy against himself. So that's the idea behind this. So the pilots, and I am a pilot, remember, they pretty much have no room for creativity or improvisation. They follow checklists. They follow processes and procedures. You give a pilot the input A, it's going to follow the program called checklist, and it's going to create the output B. So let's say that in this diagram for the attack, you have access to system A. But in order to succeed with your plan, you need to influence the system B. But they are not connected. There is no way. The graph tells you there is no connection here. You cannot jump from A to B by technical means. But what if, using the system A, you can provide the pilot with the input so that he follows the right checklist and it's going to produce the output and affect the system B for you. That's what this is allowing you to do. It's going to tell you if with the system you have under control, is there any checklist that you can trigger the pilot to follow, so he's going to affect the system B for you. And also, even if you just want to evaluate the implications of any cyber threat for any operational technology, automotive, aviation, industrial system, building system, it doesn't matter. You cannot really avoid the human factor. It's going to tell you always the same. But again, in operational environments, the human factor follows processes and procedures. Those are, in the end, just very simple and flat graphs. You just include them and you make them part of your knowledge base. And then you can affect them. So you can also add that into that scenario. Again, with no rocket science, okay? Finally, and I'm going to stop at some point because there is many options, okay? What about compliance? Okay, let's say that you want to do a gap analysis and see if any of your systems, the way it is, the way they are compliant or not. And if not, what's the difference? What's the gap? Okay, again, it's exactly the same. What you have is a set of controls that must be in place with some conditionals there. All that is linked to one target system, and all that is just another attribute for that system. And I just realized that somebody with a camera must be crazy because I don't stop. Sorry for that. I just walk. So we include that also. And in the blink of an eye, I just was selecting sorry, my mind. Anyway, by selecting another additional data from this target system, you can check the compliance and the gap analysis for the compliance of that system. Now, how is this helpful so far? Okay, and that's the key of it. That's the reason that I got into this in the first place. One of the first the problems that people in our position dealing with the cybersecurity of complex or non-complex operational environments is that usually the expertise is spread across different or many teams and different expertise. Okay, for example, you have the engineering in an airplane, they know the airplane. You have the pilots, they know how to fly the airplane. You have flight operations, you have service delivery, you have IT, you have cybersecurity, and each of them has an individual piece of the cake. Have you ever tried to say, okay, if I have to do cybersecurity, I don't know, risk assessment of an operational technology, I'm going to create one of these beautiful multidisciplinary teams, put everybody together in a room, and just get the knowledge flowing? I did, many times. And I'm lucky if there is no blood within 5 minutes after the meeting starts. Okay, the engineers say, okay, why I'm here? The airplane cannot be hacked. I've been doing this for 20 years. And I know that the airplane can be hacked. And that's it. And they leave the room. The pilots, flight operations, they say, well, maybe it can be hacked. I don't know. But I'm the pilot. I will have the control, so I don't care about it. And they leave the room. And the cybersecurity tell the engineers, you know what? You don't even know your airplanes anymore. Okay? Because now they are flying computers and you don't know about computers. And that's it. By the end, you're alone in a room. Now, you may have heard about these red, blue, and purple profiles. Why? Because engineers talk in red, IT talks in blue. So what we need as an industry is purple people. People that has the knowledge of one side, the knowledge of on the other one, and they also want them to have the business perspective as well. Right. And it's great. It's a great idea. Those profiles are very, very nice to have. But how many are there? How many people do you find with solid cybersecurity expertise and knowledge, solid engineering expertise and knowledge, the business angle for things, and also communication skills to be able to facilitate the communication? 1 in 100,000? It's not easy. Have you been trying to recruit people for that lately? Operational technology, cybersecurity? It's just a nightmare. What you have here, actually, okay, it's a tool, or at least the root, the seed for a tool that makes that happen. Why? Because you get into that room, the engineers, you press a button and say, okay, this is the systems diagram of the system we want to take a look. Do you agree or not? It's in their language. It's their engineering systems. They go there, they say yes, no. They say, no, what is different? This, and that. And you just change it until they say, yeah, I like it. Great. Then you go for the next button. And you say, okay, so the target is going to be this. Those are the attack patterns that apply to this. Cybersecurity guys, do you agree or not? By cybersecurity, even the VAPT, the offensive team, whatever you want to call it. They can say yes, no, they can change that. And you continue then with the blue team, the CISOC people. Okay, those are the rules that we have in place. Those are the sensors that we have in place. And this is the incident response that we have in place. Do you agree or not? And even if one of them is not on the room, in the interim, you can continue without them. And that's the key, because you can give that tool only to the risk management team, and they can perform the risk, usually in my case, threat model-based assessment of the system alone. That in an agile environment works like a charm. Because yeah, then later it can be challenged by some of the teams. And then you go back to the design table, you do the tweaks and the checks. But it gives the risk management team independence from all these multidisciplinary teams that in the end are a bottleneck and a stopper for any cyber risk activity. And you know that. You've been there. With that, if you are in a more agile, modern type of environment, and risk is just part of one of those agile teams or a new DevOps environment, They just do their piece and bit, they produce the output, and then if it wants to be challenged, so be it. Independence. That's one of the reasons. Why? Because I am one of those facilitators. I can go into the room with engineering, with pilots, with IT and cybersecurity, and make things flow. With my limitations, okay? I'm no silver bullet, but I can make it happen over the years. I'm a pilot, I do my share of cybersecurity, I do my share of engineering. I have enough knowledge to make things happen, but I'm one person. I try to follow the path of training people. Have you tried to upskill the people in things like that? Even if you succeed out of 1 out of 10 times, 2 months later, that guy is gone, or lady, because there's so much value on that type of profile that it's gonna receive a much better offer sooner rather than later. It doesn't work. And in any case, it does not scale. If the complexity is big enough, if the organization is big enough, it does not scale. It's a bottleneck. This is the best approach that I have managed to approach so far. Okay, and now the also non-math use case. Okay, I still do have some time, but I wanted to leave some time for questions. And I decided not to include any graph theory here because I didn't see the value. Okay, so one of the reasons more and more people is moving nowadays into graph-based database is artificial intelligence. I have here Chema. Okay, he's talking about AI in 9 out of 8 meetings and conferences. Okay, yeah, but he works for a company that can do that. Anyway, I read my first book about artificial intelligence 20 years ago. It was The New Emperor's Mind. Okay, and it was a philosophical approach into the implications of maybe achieving something close to artificial intelligence one day. There was not a single practical approach into that book. Nowadays, everything has artificial intelligence. Everything. Even the headphones, the phones, the laptops, the TVs, everything. Everything has the stamp of artificial intelligence. What has changed in only 20 years? Okay, let's take a look. Main components. So, is it the mathematical theory behind it, the algorithms that power all that? Could be. But if the AI is the new golden goose, and the reason for the succeed lately is that, why is it that you can actually access them from Google, from Amazon, from all the companies that are top-notch in the field? There are companies making money. They wouldn't share with you what actually gives them the money, right? So it may not be that. There's been huge advance in the math behind artificial intelligence, machine learning, and all these technologies. But it might not be the reason, right? Okay, what about the hardware? The technology is advanced so much now, okay, over the last 20 years, that actually finally we have the computational power to make artificial intelligence a reality. Is that true? Let me change the slide so you don't get too bored. Well, if that is true, how come I can go and buy from Google, for example, a machine learning accelerator for 20, 40 bucks that I can connect into my laptop and start playing with their own algorithms in machine learning? It may not be it. They wouldn't be selling it that cheap, right? They're building their own. Everybody's building their own Titan for Google and the rest. But it must not be the reason AI has changed, right? So what is it? Another topic that Chema has been talking a lot for lately, it's data. That's what has changed in the last 20 years. The sheer amount of data that those companies can fit into that technology and that mathematical background. That's what has changed. The sheer amount of data. But not just the amount of data. It's also the format that this data have. You heard about that in Facebook lately, usually not in good terms, about the knowledge graph that they have. They use it for whatever reasons they use it, but it is a knowledge graph. And there are a few companies in the world that have more knowledge about people in the world than Facebook. And the way they use this data is with graphs and graph theory. And they do what? They apply artificial intelligence for that. And that's the reason Facebook is for free and Google offers the services for free, right? Because what they need is data. And not just data, but the format of the data. And graph databases are partially the reason for the success of this lately, not SQL-based databases. Okay? So, and that's close to the end of the presentation. So, what I managed to do with my limitations, because I do not have access to sheer amount of data, but I do have access to some of it, is to create what I call the assistant, and I don't have a name for it. I know somebody's gonna suggest the classical one like Jarvis, something like that, but I would rather keep something more, okay? So what is it? Well, it is just that, okay? It's the application of data science and machine learning technologies. And remember, machine learning is just a form of AI and not the best for some topics. To, in my case, do not look for a science fiction approach. I do not want to be able to press a button and this so-called assistant or artificial intelligence to be able to hack a system or defend a system or do a full security assessment for me. That's how science fiction, even for the bigger companies. And if anybody from here or any other conference goes to you and tells you, no, my device, my product is fully AI, just run away. They are lying to you, or even worse, they don't know what they're talking about. No, what I'm looking here for is this type of applications. And that's something you can do also if you follow this approach, okay? You just use the tool, and it's going to suggest in the background to you. That's it. It's an assistant. It's not going to do the work for you. It's going to facilitate it for you. So you create a system, and you ask, please, or just even without asking, right? Those are the attack patterns that apply to that system. Do with that what you like. You know best, you're the human, right? But those are the ones that apply. Why? Because based on the last times that you have performed this type of project, those are the ones that you were looking for. You were dismissing initially the ones that only had operational impact. So I'm going to hide them for you. Those are the ones that usually you look for, okay? Those are usually the controls that are in place and that you end up doing the assessment for. It's going to recommend them for you, okay? It's going to tell you actually what are the threats, okay, that you should consider for that system, okay, in a threat modeling exercise. Because it's just going to have all the information there for you, and the more you use it, the more it's gonna be able to help. With a difference, the graph is not the type of data the assistant is gonna be using. It's actually how you use the graph. Okay, that's the data. That's what they call training the artificial intelligence. Okay, that's the part that you need to work a little bit with. But in this type of scenarios with the right data, that is much, much easier if you don't go for science fiction type of approaches. Okay? So in a nutshell, and because this is pretty much the end of the presentation today, okay, that is how I approach the complexity of such a big scenario. I just create a common database based on graph, okay, of all the operational and non-operational technologies and processes affecting this scenario. And then I select the most important ones. And once you do that and take that first step based on the risk appetite of the company, the graph is going to tell you the rest. Because then you just need to expand the scope and look for the neighbor nodes. So that's it. Thanks for all the fish. If we have questions, great. If not, you're going to have plenty of spare time today for you. Until the next presentation.